Okay, so in this video we're going to have a look at solving trig equations. In our first example here we're being asked to find two values for theta, and they've given us an equation. Sine of theta is equal to minus root 3 over 2, and we're dealing with degrees. So our first step, we ignore the minus sign and we have to get sine inverse of root 3 over 2. Pop that into your calculator and you get 60 degrees. Your next step is to draw a quick sketch of the unit circle. And this is where a minus sign comes into it. So we have a minus, my ratio is sine. We need to check where sine will be negative, and that is going to be in Q3 and Q4. So our reference angles, no harm marking these in. Okay, so sine is going to be negative in Q3 and Q4. So our approach for Q3 will be theta minus 180 is equal to 60. We get theta equals 60 plus 180. And that tells us that theta is equal to 240 degrees. And for Q4, we have 360 minus theta is equal to 60 degrees. 360 plus 60. 360 minus 60 is equal to theta. So we have theta is equal to 300 degrees. They asked us to find two values. We found our two values. Just write them out nice and neat at the end. So theta is equal to 240 and 300 degrees. And there's our two answers for part 1. Okay, we come across now to have a look at part 2. Wording here is a little bit different. We've been asked to find all the values. So if we have a look here, the 2x tells me it's 4 values. The 2 represents 2 rotations around the unit circle. So step 1 is normal. Ignore your sign. You're going to find cos inverse of root 3 over 2. Again, we're still in degrees, so that's fine. Into your calculator, cos inverse of root 3 over 2 is going to give you 30 degrees. Quick sketch of the unit circle. Okay, now check your sign. It's a negative sign. We're dealing with cos. We need to know where cos is negative. So that's going to be in Q2 and Q3. And then just your reference angles. Okay, so cos is negative in Q2 and Q3. So for Q2 we get 180 minus, last time we called it theta, we'll call it x this time, is equal to 30. 180 minus 30 is equal to x. So we get x is equal to 150 degrees. And for Q3 we have x minus 180 is equal to 30 degrees. X is equal to 30 plus 180. So x is equal to 210. So we mentioned earlier there'd be 2 rotations around the unit circle. So we have our first rotation and our second rotation. Our first rotation is the 2 solutions we've just found. So we have x equals 150 and x equals 210. And in our second rotation, one rotation is worth 360 degrees, so we're going to add that onto each angle. So x is equal to 150 plus 360. Into your calculator. You can do it in your head if you want either. So we get 510. And our second answer, we have 210 plus 360. Again, into your calculator just for peace of mind. We get 570. So from that, the values we've gotten are 150, we'll just make a list, 210, 510, and 570. Now, this is where, again, we come back to our 2x. So what we found is 2x is equal to, but we were asked to solve for x, so we're going to divide everything by 2. Okay, so we get x is equal to 75, 105, 255, and 285. And that's us done. And again, if you want to just do a quick check on your answers, this is something you can just do in your calculator, confirm for yourself, peace of mind. Our ratio was cos and it's 2x. So cos of 2 times 75, just throw it into your calculator and you get minus root 3 over 2, that's correct. Cos of 2 times 105, again you get the same. Cos of 2 times 255. Into your calculator, same answer. And our last one, cos of 2 times 285, again will give us minus root 3 over 2. So always a handy way to double check your answers. Okay, and our last part, now solve the equation for cos of 3 theta. The 3 here tells me there's going to be 6 solutions, as it's 3 rotations and 2 solutions per rotation. Now, we're dealing with radians, so first thing you want to do, convert your calculator into radian mode. Okay, we're going to ignore our sign. As usual, we get cos inverse of a half into your calculator, and you get 1 over 3 pi. So no harm converting it into degrees just to confirm what quadrant we're in. So a third of 180 will give us 60 degrees, so that tells us we should be in our first quadrant. So quick sketch, we have cast, and our answer here is positive. We're dealing with cos, so cos is going to be positive in Q1 and Q4. Okay, so our next step then is to figure out what we're dealing with in terms of our reference angle and then our original angles. So we have theta minus pi and then 2 pi minus theta. So for Q1, our angle is equal to 1 over 3 pi, and for Q4 we have 2 pi minus theta is equal to 1 over 3 pi. That gives us 2 pi minus 1 over 3 pi is equal to theta. So we get, just into your calculator if you're not confident with your fractions in your head, and we get 5 over 3 pi. Okay, so 3 theta again tells us it's going to be 3 rotations. So we have our first rotation, second rotation, and our third rotation. Okay, so our first rotation we found already. We have 1 over 3 pi. We have theta equals 1 over 3 pi. And theta is equal to 5 over 3 pi. So for us, another rotation is going to be worth 2 pi. So you can just add on 2 pi each time. So into your calculator, just peace of mind, 1 over 3 pi plus 2 pi is going to give us 7 over 3 pi. And our second angle, theta, is going to be equal to 5 over 3 pi plus 2 pi. Into your calculator, we'll get 11 over 3 pi. And then our third and final rotation, you can just take your answer from above and add on 2 pi. That's the easiest way to do it. We're going to get 13 over 3 pi. And our second answer, again, take your answer from above. 11 over 3 pi plus 2 pi. And we're going to get 17 over 3 pi. Okay, so similar to our previous question, we had gotten 3 theta is what we've solved for. So just make note of that. We have 3 theta is equal to 1 over 3 pi, 5 over 3 pi, 7 over 3 pi, 11 over 3 pi, 13 over 3 pi, and 17 over 3 pi. I have 6 numbers there, which is what I want. And our last step is just to divide everything by 3. So we solve for theta itself. Okay, so our last step now, you're going to get theta is equal to 1 over 9 pi, 5 over 9 pi, 7 over 9 pi, 11 over 9 pi, 13 over 9 pi, and 17 over 9 pi. And that's us done. There's our solutions. Again, if you want to check, our ratio we were dealing with was cos. So cos of 3 times 1 over 9 pi into the calculator will give you back a half, and so on. You can check for all 6, you'll get the same answer. And that's us done for all 3 examples.